increasing and decreasing functions. Objectives. By the end of this lesson, you should be able to read the graph of f of x, find where a function is positive or negative, define increasing, decreasing, and monotonicity, given a detailed graph of f of x, find intervals of increasing, decreasing, determine whether a function is increasing or decreasing analytically, doing algebra basically. So basically, this lesson's all about how to find increasing, decreasing functions. Let's start off with how to read a basic graph, right? So we read a basic graph like one of these down here. We read it from left to right. So we're gonna go from here to there. So from like -3 to 3, we want to read it this way, right? Or I should be going this way. We're also interested in describing stuff. So when we do that, we're gonna just use the x value. So like when does it have a vertex? When does it have a 0? All this stuff. We generally use the x-axis for that. The zeros of a function, f of x, are its x-intercepts, right? So there's zeros over here. Those are the zeros, this x-intercepts, also known as roots. So let's talk about how to figure out when a basic function is negative or positive, right? That's when we're all used to. So when's a basic function like this positive? Well, when it's above the x-axis. So when it's above the x-axis, right? When it's negative, when it's below the x-axis. So again, this is a generic function. Like here's a function like we're back in algebra 1. Hey, when's it positive? Well, from here, when it's above the line. When's it negative? Anytime it's below the line. By the way, all interested me in interval notation, right? So we're gonna do interval notation here. So it's this following one. Find where each of the following functions is positive or negative. Give the answers in interval notation. So let's look at this first one here, right? So if you're going around here, right, we look about left to right, we are below the x-axis. From here to -1, we're gonna be negative. So my function is negative. From -infinity to -1. Union, again from here to there. 1 to infinity. By the way, notice I'm using parentheses. You don't use any brackets here because you're just saying like that -1 is that increasing or decreasing. It's a point, so we just use parentheses because that -1 has no value either way. That's when it's negative, right? From here to here, your graph's below. From here to here, your graph's below. Was it positive? Well, in between the two, right? From here to here, your graph's above the x-axis. So positive would be -1 to 1. So that's how I figure out when something's negative or positive in a basic graph. If you look at this one here, when is it positive? Well, it's positive the whole way. Except for here, 0 doesn't count, right? 0 is not positive or negative. So I'm actually going to do this. -infinity to 2, union 2 to infinity, right? Because that 2 we're at 0, and that's not positive or negative. Right, and then when's it negative? Well, it's never negative, so no solution. So now do we know how to tell when a original function is positive or negative? Let's talk about when the original function is decreasing or increasing. What does that mean? So this is all this fancy talk for if you're increasing, you're walking kind of uphill, right? So that's when your graph's going up. So right here we're increasing, and then we're kind of decreasing, and then you're increasing again, right? That's a constant with a straight line. So it's just like if you're walking, right? Increasing is walking uphill, decreasing is walking downhill. So right here, right, if you're decreasing, you're going down. All the values are going lower. So it's like a little slide. You're going downhill. So that's a general idea of increasing, decreasing. Right? Increasing up, decreasing, going down. Right, again, when we read from left to right. Monotonicity, it's a fancy word you don't really care too much about right now. But mono means one. And monotonicity means it's only doing one or the other. It's either all increasing or all decreasing. So that's a monotonicity. So anytime you have a thing that's going either one or the other, it's called a monotonicity. So let's look at this graph here, right? Same ones we did earlier, but let's figure out where it's increasing and decreasing at. So look at this first one here. See how your graph's going down? Decreasing. So again, we only care about the x values though. So when is it decreasing? Well, from -infinity to 2. And then right here, you have to go uphill. Boo. That's work. So you're going uphill here. That's me sweating. So that's increasing. So from 2 to infinity. Again, x values. When you start at 2 to infinity. So increasing, decreasing. Same thing with this one right here. If we want to do increasing, let's go left to right. Well, you have to walk up this whole hill. It's up to there, right? That's increasing. So again, x values, negative infinity to 0. And then decreasing, read the rest of it. Whee! Zero to infinity. Again, x values. Again, as I mentioned earlier, notice intervals increasing are always defined by open intervals, right? Parentheses. Don't need to worry about endpoints. But that's how. So open intervals. Some books do differently. That's what's saying there. But we're just new open intervals. That's fine. So as you notice, this is kind of what we did earlier, right? Just the derivatives, right? If we're trying to draw the derivative off of this, it was all about if it's increasing or decreasing. So we could find. So next, what we're gonna do is figure out if a function is increasing or decreasing using calculus. And the way we do this is by using a sign chart. So there's actually two ways to do this. We're gonna use a sign chart or we're gonna graph. Well, I'll show you both. But the general standard way is we use a sign chart. So what is a sign chart? Well, it's very simple. There's kind of steps involved, but it's a little chart that helps us figure out where stuff's positive, negative, increasing, decreasing. So step 1, find all the values where f of x is equal to 0 or undefined. Very important, right? So basically we're going to set the derivative equal to 0 or undefined. We'll talk about that. We'll do some examples where we do undefined, but those are called critical points. So first thing to do is find our critical points. So that's step 1, find the critical points. And then we're going to plot our critical points. So let's say we got like 1 and 3 or something. Then we're going to plot our critical points on the number line. Then we do next is we want to check some values in between those to see if those are positive or negative. So you pick something between like 2, something below 1 like 0, and 4, and you just plug it into your derivative and see if it's plus or minus. If it's positive, increasing, makes sense. If it's negative, decreasing. And that's the sign chart. So we'll do some examples. Again, another way of doing it, if you don't want to do sign chart, I'll show you, is you can also graph. If it's a basic graph, you can just graph it. But the general idea is find your critical points, make a sign chart, plug in test values, and there you go. You know when something's increasing, decreasing. So let's do an example here. So find the intervals on which f of x equals x squared minus 2x minus 3 is increasing or decreasing. Right, so step 1, let's set our derivative equal to 0. So first we got to find our derivative. Bring it down, subtract 1 off. 2x minus 2. Now we're going to set equal to 0 or undefined. In this case, we don't have any undefined. Right, and then to solve it, x equals 1. That is not my answer. I don't care about that right now. We will in the future, but for now, that's my critical point. And what I'm going to do next is just do a little sign chart. So here's my critical point. Right, what we have here is two options, right? We have this side, which is the interval negative infinity to 1. And we have this side, which is the interval 1 to infinity. And what we're going to do is we're going to pick a test point in that interval. So something less than 1, so like 0 is a good choice. And we're going to plug it in. So 2 times 0 minus 2. We're going to plug it into our derivative, by the way. This is something very important. We're going to do lots of sign charts in the coming weeks. And we're doing a sign chart for f prime of x. So what you do is you plug your derivative into f prime of x. We'll do a sign chart for the second derivative. You plug it into the second derivative. So whatever sign chart you're doing it for, you plug it into that function. So in this case, I get negative 2. So this is a negative. Right? All I care about is the sign. I don't care about the number. So from negative infinity to 1, when I plugged in my test point, I got a negative value. So that's a negative. So I'm decreasing right here. On this side over here, 1 to infinity, pick a test point, something like 2. Plug it into the equation. So 2 times 2 minus 2, I get 4 minus 2, which is I just get 2. That's a positive value. So it means I'm increasing here. Right? So for this graph right here, you're decreasing from negative infinity to 1, right? Because that portion right there. And you're increasing from 1 to infinity. So again, so that's how you do it using a sine chart. The other way to do it, if you're pro, is you can just graph that, right? We should know how to graph that. We took an algebra 1. This is by graphing, right? So 2x minus 2, my y-intercept is negative 2, so you start there. You already got to find the x-intercept. That's also super important. So your critical point, that's what that's there for. So at 1, you hit it. That's why we do the critical point. So you get a graph like this. And look at the graph. Now, it's not the slope thing, because I know people are going to get confused. Remember, all we're looking for is positive and negative. So this thing we talked about earlier. Where's this negative at? Well, it's negative from here to here. You're negative from negative infinity to 1. Where are you positive at? Well, here. From 1 to infinity. Right, so it works the same way. So either way you want to do it. That's our first. Now let's move on to another one. So in this example, same concept. F of x equals negative 1/3 x squared plus 1/2 x squared plus 6. So let's do the same thing. Let's find our derivative first. So negative x squared plus x plus 6. Now again, right, I'm going to find my critical points by setting this equal to 0 and define. Now watch out for this though. So I'm going to factor this because I don't like factoring like this. I'm actually pull out the negative 1. I can't just move stuff over because we're talking about a function. We're actually talking about 0. It's just helps us visualize it. So I'm actually just going to factor out that negative because I hate negatives. Factoring with a negative in front. So I get something like this. Again, I can't just divide by negative because it's really just a function. So it's not like it's not an equation yet. And then from here I could factor it. That's x minus 3, x plus 2. So my x-intercepts would be negative 2 and 3. Right, like that. Those are my critical points. Now, so the way we do it, we draw the line here, negative 2, 3. It helps you figure out your intervals. I have this interval, negative infinity to negative 2. This middle one, negative 2 to 3. And this right one, 3 to infinity. Right, so those are my intervals. Now what we gotta do is do test points to see to see how each one goes. So again, pick a point in here, something like less than negative 2, like I don't know, negative 3. In between, 0 is always a good bet. And something more than 3, so like 4. Now you can plug into any one of these you want. I'm always been a fan of plugging into this one. Because there's a little trick to it. All you really care about is if it's negative or positive. So you don't actually have to figure out the answer, but let me show you. So let's do this one, right? So that's negative 3 minus 3, negative 3 plus 2. So you can just figure out the math, negative 6, negative 1, negative. So negative 6 times negative 1 is a positive 6, positive 6 times a negative is a negative 6. So this is a negative. But what I was saying already is that you don't really care about the number though. All you really care about is if it's negative or positive. So you can just go, that's a negative. Oh, this is going to be a negative. That's going to be a negative. Negative times negative is a positive. Positive times negative is a negative. Like, all you care about is the sign. So there's that one. We can do anything with 0, right? Plug 0 into anyone you want. In this case, actually, probably the top one's the easiest, but I'll do the same thing. So negative 0 minus 3, 0 plus 2. Again, all you really care about the sign, so it's negative, negative, positive. So this is going to be a positive. But let's go through it for people. Right, and then this is 3 times 2, so just 6. Again, all I care about is the sign, so positive 6. And then we can plug in 4 into there. So 4 minus 3, 4 plus 2. I get negative 1, negative times positive 1 times positive 6. So negative 6 again, so negative. Right, so based on this, I'm negative, I'm decreasing from here to here. I'm increasing from here to here. And I'm decreasing from here to here. Now, increasing to -2 to 3. I have 2 decreasing, so I'm going to use a little union. -infinity to -2. Union 3 to infinity. Again, that's how the sign chart works. But again, another way to do it, a little faster, is if you're good at graphing. If you're good at graphing this, all you do is this. You go, okay, my x-intercepts are -2 and 3. Then 3. And then I look, it's a negative, right? So it's open on the bottom right. It's an open down. So it's gonna kind of go like this, right? Negative means you go down. So where's the negative? Where's the decreasing? Where's the negative? Over here, where it's negative. So negative means a -2. When's it positive or increasing? In the middle. And negative, right? All because I knew the x-intercepts and I knew it was a negative graph, so I had open down. So again, it's another way of doing it. Let's find this one. Find the intervals on which f of x is increasing or decreasing, right? Same concept, just do another one. So let's find the derivative first. 5x to the 4th minus 15x squared. Right? Now look at this one. It's a little more intense. You're like, I don't know how to graph that. That's fine. That's what you have a sign chart for. Right? So we're going to factor it. They both have a 5x squared, it looks like. Let's find our critical points. Right? We want to factor and set equal to 0. And undefined, which we'll talk about. So we get x squared minus 3. Let's find our zeros. So split it. 5x squared equals 0. So x squared equals 0. Divide by 5. Square root it. X equals 0. Over here, x squared minus 3 equals 0. X squared equals 3. Square root it. Now keep in mind you're going to get two answers here. Plus and minus rad 3. Now again, you could, if you know how to graph this, you can still do it. Like this, it works the same way, but let's do a sign chart so we can see it. So now I have 3 things that I worry about. So there's negative rad 3. There's 0. And then there's rad 3. Right, so I have 4 different intervals here. Right, I could go from -infinity to negative rad 3. I could go negative rad 3 to infinity, to 0, sorry. 0 to rad 3. And rad 3 to infinity. Right, this one, this one, this one, and this one. And just like always, we pick little test points in between. So rad 3 is like negative 1.5-ish. So this would be like one choice like -1, 1. If you're not sure, just pick a big number. I always go like, oh, just pick like 5 or 10. Right? If you're like, I'm not sure what that is, just pick a big number. It's still on that side. It still works. Right? Then we plug them into our test point. Keep in mind, right, little shortcut. We're gonna plug it into here. Let's look at right here. Right, if I'm plugging into this thing, notice this is always gonna be positive. It's squared. That's a positive by default. Right, so that's always gonna be a plus. Right, so that's gotta figure out what this thing is. So what happens if I plug in -10 there? Well, I get -10 squared is 100. 100 minus 3 is 97. So it's a plus times a plus, which is a positive. Let's look at -1. Again, this is always going to be positive, so don't worry about this side. If I plug in -1, I get 1 squared minus 3 is a -2. So positive times a negative is a negative. Right, because that's going to be a negative times a positive. Over here, plug in 1. Well, same thing's going to happen, so that's a negative. If I plug in 10, 10 squared is 100. So I get another positive times a positive. Right, if you're not sure, you go plug your test points and see what happens, but that's what you get. Right, so I'm increasing here. I'm decreasing. Decreasing again. Increasing. So that's the idea. By the way, if you know your graphs from like honors pre-calculus, right, so if I start from here, that's a positive, so I'll start on this side. My zeros are here and here. That's squared, so that's considered a double root, which bounces. So again, review if you know how to do this. So you go through this one, you bounce off of this one, and then you have to go through that one. Right? And it follows the pattern. So again, if you know how to graph your polynomial functions, which is a topic you covered in Algebra 2 and pre-calculus, then it's even faster. Okay, so another one that's interesting. Find out inverse where this is decreasing. So let's do the same thing, right? Take the derivative, say equals 0. So my derivative of natural log is 1 over x. Set equal to 0. So 0 equals 1 over x. Oh, try to solve it. Doesn't cross multiply. You get 0 equals 1. You can't solve it. Not possible. But remember what we talked about? Critical points are when you set the derivative equal to 0 or where it's undefined. This has an undefined thing, right? You can't be 0, right? Because that makes the denominator 0. So that's my critical point, is x equals 0 is my critical point. I couldn't solve, when I solved I got nothing, but there was an undefined at 1 over x. So you just do that. Right, pick a point below it, like -1. Plug in -1 here, I get 1 over -1, which is a -1. Pick a point above it like 1, plug it in, I get 1 over 1, which is 1, so it's positive. And there you go. You're increasing from 0 to infinity, right here, positive, and you're decreasing from -infinity to 0. Right? That's the idea. Right? Take the derivative, set equal to 0, and find 0 and undefined. This actually didn't have a 0, but it did have undefined. Had undefined at 0. So then from there, just pick test points, plug it in, see if it's positive or negative. We're almost done. Do this one. Let's do this one here. Same concept. The reason I want to do this one because it's a little more fun for the derivative. Right? If I do f prime of x, that's a product rule. Don't forget our basic rules. Derivative of the first is 1. Derivative of the first is 1. Use the second alone. Then we switch it. Derivative of the second, e to the x, times the first one left alone. Right? Now this one doesn't have any undefined, but it does have a 0. So let's try to solve it. So c equal to 0. So the way I solve this is, you gotta notice they both have an ex. Let's factor. You get 0 equals e to the x, 1 plus x, right? Because you took the e out, just stole a 1. Split it. E to x equals 0. 1 plus x equals 0. X equals -1. That's a critical point. Now let's talk about e to x equals 0. How do we solve it? Well, remember what cancels out e? Natural log. X equals natural log of 0, which by the way is undefined. Natural log 0 doesn't exist. And actually, and keep in mind, actually, if that was my only problem, find if e is positive or negative. You have no critical points, no undefined. All you do is have a number line where you pick any number you want to see if it's all positive or all negative. So that's what you do if you have no critical points. Just pick any point you want. Is it positive? Then it's all positive monotonicity, or all negative monotonicity. But anyway, for this problem, I actually have 1 from over here. I got -1. By the way, another good one that you don't want to graph that. I don't know how to graph that. Just use critical points. Use sign chart, right? Plug -1. Do a little test point, like something less than that, like -2. Something less than that, more than that, like 0. Plug it into this. So let's do it right here. E to the -2, 1 plus -2. E by itself, guys, it's like kind of a square. It's never negative. Right? Even that, e to the -2 power, that's 1 over e squared. Right? It's not a negative, still positive, small positive, but still positive. This should be 1 plus -2, which gives me a -1. So I get a positive times a negative, which is a negative. Plug in 0, e to the 0, 1 plus 0, positive, and I get 1. So positive and positive gives me a positive. Right? So I'm increasing the positive value, -1 to infinity, and I'm decreasing the other one, -infinity to -1. Remember, keep in mind you always want to use this at your intervals. I've been skipping the interval part just because of time, but you want to write out your intervals, so it makes it a little easier to figure out what your answer is. Okay, let's talk about this. Look at this fancy, ugly thing, right? How do we find the sign chart for increase and decrease on this monstrosity? Well, first step is a review. Show that using quotient rule that your derivative equals this, and draw a sign diagram. Again, IB does this because in case you don't know how to take the quotient rule, you can still do the second part by doing this. And we're actually going to skip to show that part. We're just going to do this because of time and find a sign diagram. Now, to do that, I need to find, right, where the derivative equals 0 and where it's undefined. I'm actually going to undefined first. Now, we have a fraction here. Undefined is when the denominator equals 0. So x plus 3 squared, x minus 1 squared equals 0. You could split them, but you're going to get x equals negative 3 and 1. Just like always, right? Set that equal to 0, you're going to solve x equals negative 3. Set that equal to 0, you're going to solve x equals 1. So those are like my vertical asymptotes. That's where it's undefined, right? So part of my critical points, though. Now to find out where f of x equals 0, you could set the whole thing equal to 0 and then cross multiply. But what happens when you cross multiply? Well, these cancel out. All you have to do is solve the top, because 0 times anything is 0. All you gotta do is solve this. We split it. Negative 2x equals 0. X minus 3 equals 0. Divide by negative 2, x equals 0. And x equals 3. So those are all my critical points, right? I set the derivative equal to 0, and I should find out where it's undefined. So if I do a sign chart on here, right? It's another one you don't want to graph, do a sign chart. My sign chart is going to be, we'll have a 0 at negative 3 is the first one I see. Now I know it's a vertical asymptote, so I'm going to do like this for fun. Because I know it's a vertical asymptote. It was undefined, it wasn't a 0. And then we got 0. Put a straight line, because I know it's a 0. Then I get 1, which is a vertical asymptote. Then I get 3, which is 0. And just like what we did before, now we have like 5 intervals, right? We could do this interval, negative infinity to negative 3. You could do the middle interval, negative 3 to 0. That interval, 0 to 1. That one, 1 to 3. And this was fast. And that one, 3 to infinity. Right? And then I gotta put a test point in. So you gotta find a test point for all these. So like negative 4. Negative 2, something in between those two, something between here. Oh, it sucks. 0.5, 2, and like 4. Right? After we get our test points, we're going to plug it in. Now, so again, we can use a little trick to doing this. Look at the bottom here. They're both squared. So that has to be positive because you square anything, you get a positive. That has to be positive also. So my fraction here, I get this. Bottom is positive for sure, so I don't have to worry about that. Let's go over this top here. So all I have to do is plug into these two. Now this first one, you're negative 4. You plug in negative into here, you're going to get a positive. Right, because the negative times a negative. Plug a negative into there, negative 4 minus 3, you're going to get a negative. Positive times a negative is a negative, so negative. Negative 2, again, another positive here. Plug a negative 2 into there, negative 2 minus 3. Also a negative. So this is going to be, so it's going to be the same idea. Positive times a negative is a negative. Negative or positive, it's a negative. Again, that's me doing it the fast shortcut way. You can always just plug it in and get a number. And then see if that number is positive or negative. But it's a little shortcut way. It's just kind of looking at the signs. 0.5, like 1/2. Well, if I plug into here, 0.5 times that, it's going to keep it negative. So it's going to be negative on this side. Plug 0.5 into there. 0.5 minus 3 is going to be negative also. Negative times negative is a positive, over positive, positive. Plug in 2. 2 into there is a negative. 2 into there is still a negative because 2 minus 3 is a negative 1. Negative times negative is a positive, so positive. And then the final one here, 4, 3 to 4, my test point. Plug in 4, I get a negative because negative times a positive. And then plug in 4, I actually get a positive there because 4 minus 1 is 1. Negative times a positive is a negative. So this is a negative. So I'm decreasing, decreasing, increasing, increasing, decreasing. Right? And I would write them out like this. But for the sake of time, I'll spare you. For finding increasing, decreasing on the graph, right? So it's very simple. The concept is very simple. The execution is a little algebra work. But all you do is set your derivative equal to 0, and also when it's undefined, so set the derivative equal to 0 and undefined. Those are your critical points. And then from there, you can either graph it if it's a simple enough graph, or you can do a sign chart. Just don't forget how to set up your sign chart, right? Critical points are these lines here. Pick a point in between them. It kind of helps if you write out your intervals. And then you can just plug in test points. If you got a handle on it, you can just look at the signs. But if not, just plug in numbers. You get an answer. You can use that. That's fine. Right? And then once you're done, you don't leave it like this. I was trying to save you some time. You have to put in interval notation here. So that, union, that, yada, yada. Okay, one final idea. Now we know how to increasing, decreasing moves. Let's kind of look backwards. Let's look at this right here. This is a derivative graph. I want to know, when is f of x increasing or decreasing? Well, the easiest way to do it, it's like our sign chart, right? This is f of x, right? This is f prime of x. If it helps, let's make a little sign chart ourselves, right? -1's a critical point, right? Because you set the derivative equal to 0. That's where the derivative equals 0. 3 is a critical point, right? And look at before -1. That's above the graph, so positive. In between these two, negative. Above that two, positive. So it's the same idea. They just gave you the graph already. They're doing the work for you, right? So here's increasing. So again, this interval and this interval. Negative infinity to -1. Union, increasing right there also. 3 to infinity. Decreasing in the middle here. So -1 to 3. Right? It's the same concept. I just used my own sign chart from the graph they gave me. They gave me the graph. I made it easier myself. Right? Just to prove that point, let's do one last one right here. Right? Again, the idea here is this is a derivative, and they want to know on f of x when you're increasing and decreasing. Basically the same thing we've been doing all day today. Right? And the way I do that, the easiest way is to make a little sign chart. We got -2. We got 1. We got 3. Right? The good thing is I don't need to plug in points. They gave me the graph. Before -2, positive. Right? Probably let's try my intervals here. Negative infinity to -2, -2 to 1, 1 to 3, and then 3 to infinity. Right? Those are the intervals I'm using. Right? And the first one's positive, because I'm above the graph. The second one, well, I'm above the graph some more. So positive again. The third one, well, now I'm below it. So below the graph, negative, right? Plus, below it. Then afterwards, I'm above the graph again. So positive, right? So I'm increasing right here, and I'm decreasing right there. And that's the gist of it all.